quality. So I'm Andrew. This is my partner here, Jens. Jens has come all the way from Denmark to help us out with this. We have 2 sessions today. This is going to be an introductory session talking about the framework we've built. I'm giving you the tools to use it. And then Jens is going to do a 400 level session right after lunch in this same room. We'll dig into the queries and he'll show you how you can customize the queries for your environment. So with that, so we got about an hour with you, and there's really just 3 things we want to you to leave with. One, understand what this thing that we're calling CQM is, how we've built it, and how you can use it. We have 2 explicit things, KHIs, which one of these posters that we'll share with you guys at the end are about, key health indicators for Lync that we published, and the other is some trending queries which Jens wrote, which is the beginning part of CQM, which allows you to run in an environment and get a snapshot of where you or your customers' call quality sits. And then the last bit is CQM is really a process. It's really an operational thing. It's not something you do. It's an ongoing end state. So we want you to understand, get your head around how this is more of an operational thing, and we'll share the CQM poster that we've built for that as well at the end. Couple of quickies. So Jens' session, which if this is the science of CQM, Jens is the art of writing these queries and digging into our QoE database. So Jens' session is right after lunch in the same room. Martin down here, his team has built CQM and quality reports into the RAS, the Lync wrap that our Premier organization provides. This session, I think, was yesterday, but that shows a deep dive into that. And I'll show you Martin's report that you'll get if you or your customers are running RAS. Another guy on our team, Nick, is doing, I think, a session at the same time that's just more about monitoring servers. There's another one. And then Aaron Steele, I don't know if Aaron's in this room or not, but Aaron's got a session, I think, later today that basically says, okay, now I found the areas in my network where I'm having poor call quality. How do I troubleshoot and resolve those? So Aaron will talk a little bit more about that. So with that, I'm going to go through some introductory slides, and then I'll hand over to Jens, and we'll tag team this thing. So why do we do this? Why did we do this? When I say we, Microsoft has worked on our voice deployment probably for 5 years or so now. And we've experienced firsthand that as you grow your deployment and you push Lync out to the edges of your network and you extend it and you add different integration points with legacy PBXs or SIP trunking providers or other PSTN trunks, the problem space of quality as well as the overall quality of Lync tends to drop. And it's a really tough problem to solve because there's so many elements in the mix. So we've experienced this ourselves, and as we've started to work with our biggest customers, going bigger and bigger and bigger with enterprise voice, we've seen this repeat. So we need a way to methodically, in a holistic manner, address call quality end-to-end across your deployment and across your network. So this scorecard view that we've got up here is a customer that we worked with. We started working with about 6 months ago. And by the way, MSIT, our internal IT org, probably went through this about 8 to 10 months ago. So we started working with this one particular customer through these same processes and methodologies that we'll share with you today. And this is a scorecard that they built for their CIO. So there's a website within their intranet, CIO metrics or some sort, and you go there and you get this dashboard view, which is rendered in the same way that we've built CQM. So you see the green boxes here at the top are talking about server streams and the percentage of server streams in the target. You see they have a 2% target for per server streams, and they're green. They're hitting that target. They're actually at 1%. Same with mediation to PSTN. So that portion of the call leg from a mediation server, if you're dialing out, again, they've hit their target. By the way, this was all red when we started, and the whole deployment was at risk because of these pervasive call quality issues. So this was after 5 months of using this framework and this methodology. They also talk about uptime. This bottom view is interesting because every one of you and your customers needs to go through an exercise to determine what is managed in your environment where you actually can assert a quality SLA versus the guy, at the Aria, up in his hotel room, or at the Starbucks on a crappy device, complaining about quality, right? There's certain things you cannot control, so you need to bucketize what's managed and unmanaged, and that's what they've done down here. And the last bit on this slide I'll point out is this red box. So another very important thing is you need to talk to your users. You need to understand your users' perception of quality, and if they feel it's good enough or if they don't. And that's the pivot for your actions. So you don't want to just go off and run this stuff willy-nilly. If your users are happy, honestly, you shouldn't be here. But if you do have users or customers that are not happy about call quality, keep a pulse on those users, and then that's what they're trying to measure here in this red one. Okay, so why is call quality tough? So first of all, there's a link on this page, which is the networking guide that we released probably 6 months or so ago. And we've continued to update it, and we will actually update it after this session. We'll probably get another update in before Tech Ed. We keep putting additional queries and scripts in there to help you guys out running this. But the first version of the network guide, it's 100 pages or so, is just end-to-end. What is the Lync audio quality model? What are some typical problems you run into on the network? How do you troubleshoot them, et cetera? It's an interesting read. It's a thick read. We added Appendix C to this document, I think in October or so, and that's CQM. So we've taken everything in that network guide and we've whittled it down into a set of very prescriptive, discrete steps that you guys can then execute. And there's also an Appendix D, which is a set of troubleshooting steps to take the results of CQM and fix them. So read that thing, right? That's why the link's there. This will give you all the background for it, especially Appendix C. But here's the problem space. So here I've got a picture of a bunch of Lync users and a bunch of Lync components inside the network, outside the network, joining a conference call, doing peer-to-peer. These users all have devices and headphones as well, so that's another consideration. We also have some automated agents in here, right? You have the conferencing auto attendant, you have the conferencing answering service. Every single thing in the environment that does media, right? So if you look at this diagram, each of these yellow arrows, any one call is composed of multiple of these arrows or call legs or voice streams. And you can imagine some very complex scenarios. If all of us in this room were together in a conference call, we'd each have a media stream out from the AVMCU. And if one of you was using a crummy headset or had an underpowered PC or was sitting in Starbucks with crummy Wi-Fi, you bring the quality of the entire call down. So there's this complex set of dependencies. It's almost like a chain or a web, that if any one link of that chain, any one of these yellow lines is poor, it impacts the entire call. So what we've done is we've decomposed this into a set of 10 discrete elements so you can look at each individual one and you can remedy each individual one in priority order. So the product has a rich set of tools today for troubleshooting, and there's lots of sessions during this conference about how to use them, and CQM is not meant to replace them, and actually CQM needs them. The out-of-the-box monitoring reports, SCOM, of course, our wonderful folks on our support team, offerings like RAP. But for the most part, these are reactive tools to troubleshoot. What we're missing is a proactive framework that you can systemically implement within your ops team, within your daily, weekly, monthly processes, to keep an eye on quality levels. Even internally, as we've transitioned from Lync 2010 to Lync 2013 and operations teams have changed, we have slid back in our internal quality. So this is really a voyage. This is really something you need to implement and kind of be ever vigilant about. So I wanted to do a quick comparison of what you'll see in the out-of-the-box monitoring reports in terms of poor calls. We have a poor call flag in QoE, and what I've listed on this slide are the 5 attributes that contribute to a poor call. And there's a link at the bottom. Jens has a blog post, actually, that goes into this in a little more detail. So there's 5 values, and this is meant for you as an admin to look and get an overall sense of your users' perceived call quality across your network. And it's a whole bunch of factors, including common network characteristics like jitter, round-trip time, latency. We also have stuff like degradation average, ratio concealed sample average. Who knows what ratio concealed sample average is? Yeah, that's the problem. This is great, This is great to give you an all-up view, and you can read it, right? You should know it now. You can read it on the screen. But if you're troubleshooting a network problem and you're going to your network team and they're going, well, what are you basing this on? Well, I'm going, well, it's ratio concealed sample average, don't you know? Well, they don't know, right? So what we've done in CQM is we've made it dumb simple. All we look at is loss. And we found that loss is kind of the leading indicator of where you have a problem in your network. So we look at two characteristics. And you can change these if you like, and Jens will show you how. But basically, we look at loss over 1% and a burst of loss. So if you have a burst of over 5%. Those are the only two things we do in terms of the stream, the audio stream work we do in CQM. So that, let's see. I think make a better point of this in subsequent slides. So this is very intentional. When you're in a data center and you have an AVMCU and a mediation server and a gateway, I would expect that you would not have any more than 1% loss. Now, when you're on the edges of your network, like in a wireless subnet, sure, you're going to get higher loss. And maybe you change the targets that you're trying to reach based on that. But we very intentionally, so these charts show, these are some charts Martin did, and they're in the RAS report, I believe, that on this chart on the left, you see all streams in your whole environment. So if you added those all up, those are all the call legs in your environment. And then the orange is the poor streams we classify in CQM, and the blue are the ones we classify as a poor call in QoE. And then the chart on the right takes just those poor streams and shows the difference. So you can see in CQM, we're really highlighting, it's the same curve, but we're exaggerating. We want to surface as many of these potential issues for you to investigate as we can. So the methodology has three dimensions. It looks at things in three ways. So the first thing we do is we look at servers. You can't blame the network. You can't blame the device. You can't blame your users for being stupid until you get your own house in order. The very first thing you need to do is make sure your servers themselves are healthy and they are not contributing to loss, right? The second thing you do is we look at these network factors, and this is where we look at all the streams between these various endpoints. And the last thing we do is we look at a set of endpoint factors that would look at like the device you're using, the PC you're using, et cetera. So one thing I wanted to show is this KHI spreadsheet. So this is something we ship in the network guide. It's also something we have a poster on that shows the KHIs. How many counters do you think we have in the product? We have Skype cards, by the way. We'll give some to you. Any guesses? How many counters in Lync? Well, 1 million. It is between 1,000 and 1 million. What's that? 5,000? Oh, I almost fell off the stairs. No, it's 7,000 and change.
Yeah, so we did it for 5,000.
Yeah, you're closest. It's 7,800 and something. So every developer, when they write their bit, they instrument it because they're interested in how it performs, et cetera. And then, this keeps on accruing, and then we ship it, and the management pack has a broad assortment of them. But we really didn't have any way to whittle down what are the essential key health indicators of a server. So we whittled it down to 80. And let's see if I can manage to push this and go to this. So this is that spreadsheet, which is also up on the slide. But you'll see here there's tabs along the bottom. And this first tab is core compute resources. So we look at processor, we look at memory, we look at network, we look at disk. And that's your first place. And if you're constrained on any one of those, it's going to have an effect on the Lync capabilities. And that's what these subsequent tabs do. So we look at some specific counters on front ends like Q latency, Sprock latency. We have SQL counters. We have MCU health counters, et cetera. So you work your way through this guy. And we have a script that instruments these counters so you can collect them on a machine. But one thing to point out, for example, on this example, you see that these front ends have pretty high levels of loss, right? They're peaking. And actually, we had another customer that we did some work with very recently, and we saw that they were showing poor streams between their AVMCUs. They had standalone 2010 AVMCUs and their mediation servers, right? So people dialing into conferences. And we couldn't quite figure out why, because the servers were co-located. I think they might have even been in the same rack, right? But when we looked at the KHIs, like 3 of the 4 or 5 front ends had this really high packet drop rate on both send and receive. So there's a problem with a NIC driver, problem with a card, problem with a switch port. I don't know what it ended up being. But it turned out the servers themselves, in this case, were the source of loss, not network or other. Anyway, so this spreadsheet is available as a resource for you guys to help do this. And we continue to work on building this more natively into the product. Yeah, question? No, you run it for a duration, like a week, and stick it in the spreadsheet and see how you're doing. We're looking at ways to get it into our shipping management pack and other ways to make it easier. But that's the way to kind of do a point-in-time inspection. Whoops. Okay, so that's KCHA's, that's intro. I'm going to turn it over to my partner Jens here.
Yeah, first I will apologize that I have a cough. So let's see how it goes, and otherwise Andrew will take over. So the source of the data that we look at in the quality of experience data is being sent by all media endpoints. So all clients doing media sends after each call, they send a report to the server using the zip channel. And that report is then added to the database and is the base of what we look at in our queries. And if I can get this to work.
This guy.
Yeah, but you see, what we're looking at is the packet loss, and that is reported from the client here. And you can actually, if you are very interested, you can get this XML block yourself. If you look in your client's UCC API log, you will see this report. Yeah?
All that data is available in monitoring server as well.
Yeah, so that's the monitoring server. In the monitoring server or in the monitoring store database is where we store it. And the database is called QoE metrics. That's why I called it QoE. So sorry about that. But that's the same.
That's the same data.
Yeah.
So you say all devices or all clients that have media, that includes analog phones?
No.
I
All
guess we should repeat
clients
the
running
questions.
Lync software. And even the Exchange, if you saw, the Exchange is also sending in reports.
So the question was, is all device there like an analog phone? So it's all Lync endpoints that'll send a record into that database.
And there are even some third parties who can send in QoE reports from their device, so like Ziptrons or PSTN gateways can also do it.
And this includes mobile devices as well?
Yes.
But not being optimized for influence, don't they?
I don't know if they do it.
I know for sure that SNOM doesn't do it.
Okay.
I'm not sure about AudioCode.
Okay. That's a good point.
Well, what happens if the device can't send the data? Does it catch it until it's able to stop?
Yeah, we have a queuing. We used MSM queue. So the question is, what if you can't send it? So if the server's unavailable, it'll queue it.
Yeah. Okay. So for that database, if you are in a migration or coexistence scenario, you will have both Lync 2010 and Lync 2013. And there you have to be careful because each version uses its own version of that database. So if you have users on 2010 talking to users on 2013, you will only see one stream in the 2010 database and one stream in the 2013 database. So the conclusion there is to make sure that your coexistent phase is very short. Because there is we don't have any tools to like consolidate it, and we have worked with customers who have tried to build tools like that themselves, and they have stopped doing it. So it's quite complicated. So the advice is to make sure that you have a quick migration. The databases themselves also have different schemas, and I have listed the URLs there. So in 2013, we have some new stuff. The most important one is that we now support video and application sharing media streams. We have new ways of storing the network information, the subnet and IP addresses, to make it easier to work with. And as Andrew mentioned, we have the classified poor call flag. In 2010, that was placed in one table in the database because we only had audio we could flag as poor. In 2013, we have moved it to another higher level in the hierarchy because we have the same flag for both video and application sharing. And we also built some views, so if you are coming to my session after lunch, I will talk a lot about inner joins and tables and rows, and if you're not too fond of working with that, then we have built some views for you that you can use directly. And another thing I would like to point out, the best practice is to have a single instance in your environment, and that's because of this problem with consolidating data. There are some customers who have some legal obligations to maybe have multiple, so they will have to live with this problem of consolidation. Okay? Yeah?
When you say single instance, it's 2010 server and 2013 server.
Yeah, so if you have a 2010 deployment, you should only have one monitoring server in 2010, and if you have a 2013, you should only have one monitor store database.
Question? Yeah?
What about geographical pools? If you're running, say 3 different pools across the enterprise, do you still,
Yeah. So the question is, if you have geographically dispersed pools, can you have a single monitoring server? Absolutely, and you should. We have customers that have huge geographic deployments. They have one monitoring server, and that's fine. It's not user impacting. If there's latency to get there, we just drop in records in the database. Yeah?
I think you just answered, but any WAN concerns with that, or is it because of the queuing and it works out?
I mean, sure, you don't want it at the end of a DSL line, but as long as it's on your managed network, it should be fine. Sorry, the question was if there's any latency concerns.
Yeah,
with the
it is basically that XML blob being sent by MSNQ in 2010 and another mechanisms in 2013. So it's not huge data.
When Jens had that slide with that little blob that's in XML, that's all that's getting sent. It's just a text entry.
And just to be sure, the same thing also affects CDRs. So I'm just talking about QoE, but there is a similar implementation for CDRs or for call detailed records using the same technologies to move
Separate
it.
database, but same mechanism.
So when we are talking about the network's coverage, let's imagine we have a network like this. We have a data center with AV MCUs. We have an edge server. We have some mediation servers, PSTN gateways, and we also have another site with local mediation servers and gateways. And then we have users all over the place on internet and inside the network. So how are we looking at these different media streams, and what query looks at what media path? So if we start by looking at server-to-server streams, as we call them, we have 2 queries, one for AV MCU to mediation, and one for it's the same query, but it's just showing where they are running. So this guy will pick up all streams between mediation servers and AV MCUs. Then we have another query showing mediation servers to gateways, to PSTN gateways. And for the end users, so looking at streams for a client, from a client to a server, we have the wired and wireless streams, queries, and they look at Lync clients talking to AV MCUs or mediation servers or PSTN gateways. And then we have a tool to pick up streams coming from the internet. So if you go through the internet, through the media relay in the edge, it's just relaying the media. It's not generating media, and it's not generating QoE reports. So we have this tool called Pre-Call Diagnostic, which you can run on your desktop or your modern client, and it will talk to the media relay and show you network statistics from the link between your client on the internet and the media relay.
Has everybody used PCD? So we just shipped a new version of it a month or so ago, and it's really nice for your end users to see what's going on, and it does give us exposure to that one edge area where we don't have QoE data. But otherwise, we're covering the whole network with these queries.
But it's important to understand it's something you have to ask your users to do if they have a problem. It's not something that automatically will send stuff into the QoE database. Yeah, question?
Do you have it on Mac?
No, it's only available. So the question was, is PCD available on Mac? And the answer is no, it's available on Windows.
There's two versions. One is a traditional client and one's a modern client.
But I will take the feedback with me home and tell them that they need to. They need to do it for the Mac.
So
Yeah?
the PCD collects data and sends it.
No.
No, it talks to the media relay, sends packets, and then it shows it in the UI to you as the end user. And then you need to note it down and say, oh, it counts, it draws some graphs, and you can see if you have packet loss or if you have jitter. And then it's up to you to do whatever with it you want.
Is there a reason the product team decided to create another tool called PCD rather than including it into the audio quality test is already included in the time?
They have different purposes. So the audio quality test is meant to be a very end-user friendly, easy, I'm in a hotel room, how's my audio? Sorry, the question was what's the difference between the built-in tool and PCD? PCD, honestly, we found it very useful to us as we rolled out Wi-Fi on our campus. We began using it more and more for our end users, and we found it more of an IT admin tool. So as opposed to for every one of your users, it's more of an IT admin toolkit. We decided let's ship it. Other folks can get use of it too.
Okay. So Andrew mentioned that we have some queries looking at how the endpoints are doing. And I've listed the queries we have here. We have one for endpoints showing the send, listen, MOS coming out of the device that's being used, the capture device being used on the PC. Then we have another query looking at the microphone glitch rate. And that shows if the system is under stress and if that's contributing to audio quality issues. Then we have queries looking at the media path. Which one looks at relay. So the idea is you are on the internal network, but we want to see if your streams are going point to point or if you are using the internal edge to relay your media. That's not the most optimal path for the media. So we want to flag those streams and enable you to fix your network. It's typically a firewall or router configuration problem. It can also, and it might be valid in that particular deployment that they want everything to go via the edge, but it's not the optimal. And the other thing we look at is VPN. Best practice is not to run media over VPN, so we have a query flagging those streams. And again, it might be something that this particular deployment require all users to use VPN, but we just want to show the queries, and you can see if they contribute to the bad quality. And finally, we also look at transport. So the optimal protocol for doing media is UDP protocol. We can also do TCP, and we look at streams running over TCP, again to surface it as an indication of a problem configuration in your network. Then we look at these different tenants. So we have the structure. We want to see things from end to end. And we want you to look at it from the inside out. And that's also related to the way we are looking at networks. As Andrew discussed, you want to focus your efforts on the things that you can control. So the managed network, maybe the data center network, the office wired network, maybe also the office wireless network. But then you want to leave the unmanaged network, so external internet or Starbucks or whatever. You want to leave that maybe to never look at it again, or leave it to the last because there is really nothing you can do to improve the quality in the Starbucks Wi-Fi network. And then the last tenet is the service aspects. You should, as Andrew discussed, you should see it as a process. When we did this inside Microsoft, we worked, and we saw downwards trend, and everything was was great, and people were, yeah, we did it.
We're finished.
But then, after a couple of months, the trend started moving up. And it's coming from changing in the environment, which are affecting the audio quality. So the message here is, it's not a short-term journey. It's something you have to do, and then continue doing it, and monitor the quality.
One of the things we did internally is we built a process where we get an email daily of certain things that we knew were problematic, like the mediation to gateway streams and the AVMCU to mediation streams. And there'd be a triage ops call every morning to look at the top offenders that would float to the top of the list, and we'd talk to the local IT guys and dispatch folks out there to take care of them. And what we found, as Jens said, is as new gateways are introduced to the environment, firmware updates happen, router configs change, configurations drift. So we invested in tools to make sure our Catalyst 4000 switches, whatever our standard is, have a standard build that's enforced. And same with our gateways. We have a standard or goal configuration that's implemented. So you want to build a process to keep looking at this stuff ongoing.
And that's also part of the tools box we have here. So this golden config, both on your PCs, devices, and in the network configuration, and have some tools to make sure that these devices keep using the golden configuration. And the last point is the user experience. What we found working with the customers is that it's very valuable if you create like a script for your help desk. So if people call in with bad audio quality, you want to ask them a specific set of questions to make it easier for you to troubleshoot what the problem was. So having these kind of tools, and maybe also having end-user surveys. So as Andrew mentioned, that customer we have been working with have a system to send in surveys after calls. So they can directly link what the end user felt was a problem with what the data we have in the QoE database. When we work with these things, we create graphs like this one. So this is internal Microsoft Streams distribution in this time period last year. And you can see the green box represents good streams, and the red represents poor streams according to our definition. So we have, Andrew will give you a card if you can tell me why.
I'll give you 4 cards.
The MS to gateway stream here, why is it not existing? Jürgen? Yeah?
Good job.
Okay.
Very good.
So the answer was it's media bypass. So inside Microsoft, we use media bypass. So we talk directly to the PSTN gateway, and that's why the streams are not showing up. The other thing we are doing is we are looking at the poor stream distribution. And in this case, you can see that it's the external, the red, this guy here, has the majority of the poor streams. It's coming from external clients talking to people inside. Yeah? For what?
Question is media bypass for wireless. If they're mobile, no. Wireless, yes.
Yeah. Okay.
And on one point on this, so as you start to do this analysis, look at that big red pie slice. You're probably just going to want to redo that graph without that, because external is a big problem, and you're not going to be able to solve it. Focus on your internal managed network first, and then figure out why your users are trying to make calls over Wi-Fi and Starbucks, and you can deconstruct that. But focus on the managed network first.
So I will try to do a demo. So before I start my demo, I want to show you the result of the demo, just to be on the safe side. And you can see it takes 5 minutes and 31 seconds to run the query. So I need to talk rubbish for 5 minutes and 31 seconds. So let's
give out more Skype cards while you're talking.
Yeah. So let's.
Yeah, question. Yeah, so what Jens is showing is, what's this called, Enterprise Manager?
Yeah, so this is SQL Management Studio. I have opened, looking at a copy of our production Microsoft IT database. And you need, so the way we distribute the queries is we distribute them as text files. So before recently, the way you would have to do it was to open the queries in a text file and paste them into the query window, as I have done here, and then execute it, and then copy the data into a CSV file and load it into Excel.
But we realize as we've started to work with more and more customers that that's not necessarily something every customer can do. So we have a script that we'll share with you today. There's a link in the deck, and Jamie tweeted it earlier, that will run these for you on any Lync front end. And it creates a bunch of CSV files, and we've also modeled how it looks in a spreadsheet. So we'll go through that later in the session.
So that takes the pain out of running the SQL Management Studio. But you still need the permissions, right? We use the SQL client through PowerShell to run the scripts and output the data to CSV file. But then you need to take them, import them into Excel, and do your stuff with it. So I have here the AVMCU2 mediation query. And I would just be showing you the structure of the query, and my session after lunch will be a lot more about these things. So I will live in SQL Management Studio after lunch. So if that is not what you like, you should find something else.
It's the perfect thing to do after lunch.
Yeah. So we are doing some joins on the different tables and looking at UA types. So UA type is like user agent type. So each client have a user agent type. So the desktop client is user agent type 4, mediation is 1, and AVMCU is 2, or the other way around. But that's basically how it works. And then when we look at this query, based on the media path we want to look at, we specify the UA type. So in this case, I only want to see streams between UA type 1 and 2, which is AVMCU mediation. And I want to see streams inside. So both caller and callee would be inside the network. The assumption is that no one is placing AVMCU and mediation servers outside the internet. It might also be impossible in the topology builder to do it, so I think it's a fair assumption. Then we create some views and just sum up the different streams, counts the stream, and counts the streams that are poor. So if you...
Don't forget the criteria.
Yeah, exactly. So the criteria is here.
That's what we talked before. It's the two things we're looking at is loss over 1% or a peak or max of 5%.
And this is the same sentence we use in all the queries. And if you want to look at something else, this is where you would change it.
Yeah, we worked with one customer who, for whatever reason, had latency problems on their network. Round trip time was problematic for them. So in their case, we replaced this or added round trip time in addition to latency. So you can modify these if it makes more sense on your network. But again, the idea is keep it simple, right? So we don't want to throw in ratio concealed sample average and all that stuff.
While it's executing, I still have 1 minute of crap to say. So let's look at the spreadsheet. So the spreadsheet, you can see here, that's how I look at the data when I get the data from the customers that we are working with. So I'm creating graphs like this where I can see how the different customers compare. And then I create a trend chart like this. So let me try to... So here I'm looking at the trend for wireless P2P calls and wired P2P calls. So that's wired clients talking to each other and wireless clients talking to each other, and there is no crosstalk in these queries. So here you can see that the wireless streams, so the blue one, have pretty poor streams. So this is the ratio. So nearly 60% of the calls are poor based on our condition for the wireless calls, but for the wired, it's like below 5 or 3 even.
The trends become really interesting as you start running this more and more. After you kind of get through the initial phase of figuring out where are the hot spots on your network. When you see problems spring up again, you start to see stuff trending up. So one of the customers we worked with, it was mediation to PSTN. And you could clearly see over the past month that the poor streams are going up and up and up. So that's a point where you want to dig in and figure out, okay, what mediation server or what gateway or what switch in my network is now contributing to that.
And it's also interesting, we have worked with customers where this picture was reversed. So they had better wireless quality than they had wired.
They had invested very recently into a new wireless plant, and their network guys were all spun up about it. So they did a better job. It's a strange one. Yeah, question?
Can we run this on a multi-tenant setup?
On multi-tenant? A Lync Online multi-tenant?
So the answer is no. So the question was, can I run it in multi-tenant? In multi-tenant, you don't have access to the QoE database. So not in multi-tenant. You might be talking about dedicated.
There's the simple answer to this, regardless of what variant you're using. If you have access to the QoE database,
you can run it.
You can run this. Then you can run it.
Okay, so you're not talking about Lync Online Office 365. Okay.
Sorry.
Okay.
Was there another question back there? Oh, yeah.
So you reported that graphic. Is it enough for you to convince the wireless team that they should improve their network, wireless network? Or you need another data?
Yeah, so our experience has been that they are not accepting our data like at face value the first time we tell them.
That's why we focus on loss. So if you can go to your wireless team or your network team and say, look, between these two endpoints, whether it's a subnet or whether it's a leg between a mediation, I'm seeing loss. Then you at least can work together to identify where the loss is, and they can use their tools to corroborate that they see the same loss.
You should also prove that the data was not caused by server performance.
Right, so that's why we started, I showed the KHIs. Start looking at your Lync servers. And we'll go after this into how to structure this in order.
And the other thing to say is that sometimes these numbers are inflated because of configuration problems. So you can't just assume that this is actually what is happening on the wires. You have seen max packet loss rate of what we report, but it was caused by something, and it might be just have been a small spike. So that's why you need to look at the networking guide and go through Appendix D, which tells you how to troubleshoot exactly this problem, how to show that what has been the actual cause of that packet loss rate.
Yeah, we had one example where we were seeing high loss, and it was actually root cause turned out to be comfort noise was misconfigured on the gateways. So we weren't getting comfort noise packets, and we were reporting that as loss. Yeah, you're good?
Do you have a collection of common mistakes?
Yes.
Collection of common mistakes in the network guide?
Yes. I want to stop talking rubbish, so you can see
that was not rubbish.
that my query finished, and I produced some results. So the idea would be now, before the script that we publish for you guys, is just to copy with headers into Excel, and then do Excel.
Go back to the table for a sec so I can see. So you see in this output, basically we've got all streams on a particular day that go from AVMC to mediation. So we had 3,268 in that first row. That's probably a weekend day because you see they go up. That's probably the next 5 days are a weekday. And then you can see the poor streams are a fraction of those. Those are the ones with 1% or 5% max. And then this ratio is what we trigger on. So that's how we decide if we want to look at a particular pair, a hot pair, is by how big that ratio is.
Yeah, and you will also see, when you start working with this, you will see interesting spikes in the data. So when I was looking at our data, I saw spikes around 18 and 19 August last year. And that's exactly the time where our performance review are made public. So that was people talking to their managers and getting the message if they were fired or kept on.
The other interesting thing we saw when we were looking at data is apparently everybody at Microsoft stops working about the third week of December and doesn't come back until like the third week of January. Everything just bottoms out.
Yeah. Okay, over to you, my friends.
Thank you. So we got kind of a 10 commandments of CQM that I'm going to go through that'll kind of try and wrap up all the stuff we've shown you. And actually, this was kind of serendipitous. As we were building this framework together, it just happened to come out to 10. So there's 10 buckets that this stuff falls into that you guys can walk through. And whoops. There we go. So it's those same 3 dimensions I talked about before: server, endpoints, and last mile. Those are the 3 ways that we split this guy up, right? And within each of those dimensions, we've got a set of areas. So server plan, I think, has 4, and endpoints has 4, and last mile has 2. And we do the same exact thing in every single one of them. So the first thing you do after you run these and you kind of get an idea of the baseline of your environment, you set some targets. You figure out what should my target be for poor calls, and you determine that, poor streams, and you determine that based on feedback from your users and what your tolerance is. Different customers have different ideas of acceptable quality levels. So our default is 2% poor streams. You may up that, you may down that. You decide the thresholds. Whoops. The second thing you do is go through a prioritization exercise, and I'll go through that in a little more detail. But basically, you run all the trending queries and all the baseline queries, and you get an idea, okay, where am I in the most pain? Is it an endpoint problem with devices? Is it a managed network problem in my data center between particular server types? Is it a problem at the edges of my network on my subnets that my users are on? And then the very last step is you implement process and tools around this to make this a continuous iterative process of improvement. So in the next set of slides, we've got kind of these bullseye charts that deconstruct that very first diagram I showed you with all the yellow arrows. So now we have smaller pictures with a smaller set of arrows. So we're just honing in on those particular areas. And then the areas that we start with, the higher priority ones, are in the middle, kind of ring 0, if you will. So in this case, to the gentleman's question here, we start with our servers. So the very first thing you got to do is make sure your own house is in order, make sure your Lync servers are not stressed and are not contributing to loss, don't have bad NICs, et cetera. The next thing you do is you look at AV MCU to mediation, which is the query that Jens just showed you. From there, you look at mediation to gateway. And then gateway out, we don't have visibility into that call leg for the most part. So you need to go to your telephony guys, or maybe that's you guys, and figure out what are the right health statistics to look at for that call leg. There's some Sonus, I believe, announced, because when they're doing SIP trunking, they will actually collect QE data on the far side of that leg, and they will put an entry in the QE database. So we can do it in that particular case, but not all gateways and SBCs have that. Yeah?
So you asked about QoE from the Mac client, and I said no. In fact, they do send in the QoE. I just realized that.
No, you asked about PCD.
Ah, PCD, sorry, yeah.
So Mac client will send QoE, though, yeah. All Lync clients will. Okay, so here's the a little more detail on those 4 elements. So the server plant, server health is those KHIs. Collect those, take a look and see if you're red. And if you're red, remediate before you move further. The next one is AVMCU to mediation and mediation to gateway. Those are the server-to-server streams. We get a broad network coverage in your managed data centers from those streams. And here's where we look at the 1%, 5%, really low threshold. For example, in the poor call flag, it's 10%. But we're only looking at 1%. So all the problem areas are going to pop out when you do that. So figure out where the problems are, and then you can kind of triangulate on your network as you look at the pairs of servers. What are the network elements between those pairs that are problematic, and focus your troubleshooting there. And then last is gateway to PSTN, and that's the one that's a little tricky, and you got to figure out for your individual deployment, are there gateway stats? Do the trunks have enough capacity? If it's a SIP trunk, then you can get some IP stats off it, similar to what we're doing here. So that's server plant. The next is endpoint. So endpoint, the first thing we look at is the device. That's our kind of ring 0. And we'll pull out MOS scores based on device. And if you've got poor devices in your environment, take a look at those and fix those. Next is system. We have found systems that are misconfigured. This actually is pretty prevalent. Maybe it's AV scanning. Maybe it's just an underpowered machine. Maybe there's other apps taking all the processing power. It adds glitch to the call. In that case, the PC, the system, the Mac is actually the source of the poor call. So we'll identify those. And then the last 2 are media path. And that's if we're doing an internal relay or we're using TCP instead of UDP. Both suboptimal. We want to point those out. And the last is, VPN or internal relay as path. And then the last, media transport, is if we're using TCP instead of UDP.
I'll just add one thing with the glitch rate. We have seen customers having very poor quality caused by, and we could see that the glitch rate was high, and it turned out to be storage drivers running with wrong interrupt levels and hacking the CPU. So it can be strange things, and it can take a long time to find out what the problem is.
But this will show you at least where
Yeah.
the problems are. So a little more detail on these guys. So what we found is 3.6 is about the good cutoff when you look at kind of the distribution of MOS scores for devices. And so we look at devices that are giving you a MOS score lower than 3.6. And then we aggregate those, and we look at the devices. And you'll find some surprising things. In a lot of cases, the integrated speakers and mic are good, especially on newer laptops, and those will actually give you really good scores. And you'll see older USB devices with poor scores. So it may not be what you expect. We always say use a qualified device, but the data doesn't lie. So you'll see what devices are actually causing you problems. The next one is the glitch rate that Jens mentioned. We want that to be low, and we've seen customers that are off the charts on this. So I think this is a kind of an untapped area. If something's configured wrong on your PC, surprise, that can cause audio problems. Media path, we don't want media over VPN. You just shouldn't be doing that. So we have a target of 0. We do have some customers, that's the only way they'll allow it. They don't have edge, so that target would change then, if that's what they're asking their users to do. We don't want calls relaying off the internal edge. We want calls flowing peer-to-peer, so we identify those for you. And finally, we don't want TCP, we want UDP. And this last one's funny. I worked with a customer very recently, and they swore up and down there were no firewalls. There was no way any of this could be happening, right? But obviously it is. So it's really hard to have these conversations without data. So show them the data and say, look, let's just work with you and figure this one out together. There's got to be something that's not letting me negotiate a UDP session. And finally, last mile. So this is the segment at the end of the network from your subnets out in your branches to the next hop server. So you got to remember, that's how we're measuring this last hop. It's from where here I'm sitting, and if I'm talking to a Lync server, AVMC or mediation, that's the QE data we're going to get. So it's that path. And again, we're looking at the same characteristics, 1% or 5% burst. But here you need to get a little more creative. You'll have sites that have very low streams, a lot of users. Don't focus there. Focus on the sites where you've got a lot of users, a lot of streams, and a lot of poor calls. So consider as you're looking at this how many streams you're looking at, and then what we've kind of shipped as the default is 5% poor for wired and 10% poor for wireless. But again, if you're that customer that's really hot on wireless and you want a great wireless experience, then modify those thresholds accordingly. So we got 20 minutes. Let me take a breath there for just a minute, because the next set of slides is, okay, now, how do you do it? How do you get started? And we'll show you some ways and tools. But I just want to take a minute, because we've thrown a lot at you, to just give you an opportunity if there's any other questions on just how the framework works and how we're executing against it. Yeah? Turn off, sorry, so the question is, can I turn off seeing those relay calls?
Yeah, can I have that not be a factor in determining quality?
Oh, yeah. I mean, this is a framework. It's entirely up to you. You can just choose not to run that query. Yeah. Yeah. Okay, so that's a feedback item. Jürgen's point is if we would be smart enough to behave differently when we're on VPN. So Martin's mentioning the split tunnel blog post as an option to that. It's an interesting problem, but fundamentally what we're trying to do here is surface the potential issue to you. And then you decide for your customer, just like your relay point, if that's intentional, great, move on. But if you're finding a whole bunch of people are doing media over VPN and they're getting cruddy calls and that's not what you want to do, or you have a plan to fix it like doing split tunnel, then do that. Yeah, one of the things Jens will show in the afternoon is if we don't flag a VPN call because we don't understand the VPN software concentrator that's using it doesn't tick a flag, how to just put in subnets for your VPN so you can report on it. Do you have a question way back there in the corner? So the question is, how does this apply to virtualized environments? So there's a couple sessions on virtualization specifically. There would be no difference in this framework in a virtualized Lync environment versus a physical one. And we don't have a lot of experience with running this framework in a virtualized environment to answer your question to see if the results are significantly different. Okay, I don't want to, one more, and then we'll close.
Just go back to the whole subnet and VPN. The SSL VPN is so difficult to tag that information. And because the clients get assigned a unique subnet every time they come in, can we superset those subnets so that we can say anything that comes in? And we've tried through the client, it doesn't capture anything.
So the question is how to capture VPN subnets when there's a broad range of them. I don't know if Jens has an answer. I don't.
No. So what I nodded to was what Andrew alluded to was that my queries, you can train the queries to specify the subnets that you know are VPNs. So we will use them instead of the VPN flag. Okay. And that's what I will show you after lunch.
Oh, okay.
All right, so I don't want to mean to interrupt. We'll be here after the session. We'll stick around for Ask the Experts. Oh, that was yesterday. We won't. But I don't want to cut off any questions, but I do want to get through the slides. So real quick, let me pop back to here. So here's our process. I think we've talked about it before. Basically, do this baseline effort, this first go at this, figure out where you sit, go through a prioritization effort. You can't do all 10 things at once. Pick the biggest hit to give your users the best bang for the buck to improve quality. Start there and then work your way through. Remediate problems and then operationalize this. Here's a quick example. So this is a customer we started working with last month, and we had them run the trending queries. You can see this customer, see on the side, on the end there, there's no external, there's no VPN. These guys don't allow edge, right? They don't allow media outside. So that's, but you can see what's the biggest problem spot that pops out, right? In this case, it's this guy, it's mediation to gateway. That's the highest percentage of poor streams they have. That's the red bit. So what do we do after that? So that the trending query points that out. Then we run the detailed query, and this shows, well, first of all, you see the trend, right? They're trending in the wrong direction. So the number of poor streams for this area are getting worse, mediation to gateway. So then what do? Then we run that detailed query, and it'll show me all the pairs. It'll deconstruct that total number into all the pairs. So I'll see here I've got these top, it's sorted by poor streams ratio, and I'll see that, this first row, 35% poor streams. That's bad, right? But there's only 142 streams between that pair versus this guy that I've put in bold has got 4,000. So I'm going to skip that guy, look at that 4,000 guy, 880 poor streams, 21%, and I can start to see trends that this CA mediation 301 is having problems, and when it's talking to these JP gateways. So what does the network look like between those two devices? If I'm sure those servers are healthy, there's got to be something going on in the network between those two devices that's causing a loss, that's pumping up this number. So that's the point where you talk to your network guys and you start to troubleshoot that. Okay, so let's pop back to here, and I want to show real quick what our support guys have done in the wrap. So there's a really sweet report that they've written, which I don't have open. All right. My bad. I'll open it if we have time, but I don't want to pop into Outlook. Martin's actually the author of that report. It's really slick. So as you get your head around this can be a lot for some customers to do. If they have RAS, a quality report will be one of the reports they get, and they can run this anytime they want if they use the RAS service. And it'll show the total streams. It'll show what's managed, what's unmanaged. It'll show the poor percentage, and it'll actually deconstruct it to the level that I was at on the previous slide, where it shows where the problem areas are, and specifically the gateway, the mediation server, the AVMCU areas that you want to look at, or if you've got device problems, et cetera. It goes through all 10 areas and spits that out. So that
it will also have text explaining, a lot of documentation explaining what the problem are, could be helping you in troubleshooting this, basically taking you through the process that Andrew has talked about.
Right. So that's one bit that we've got, and the, oh, sorry, is there a question?
Yeah. So everyone can run the scripts that we made available, but I believe you need to be a Premier customer to run the service.
So here's what you do if you're not a Premier customer. So this is something that we just put together to make this easier for you. So this is just a spreadsheet. And you can see, let's see, do I have Zoom it loaded? Yeah, okay. So you can see on the left here are all 10 of the elements that I went through, right? From server, they're organized in the same way. So server plant, and we'll show the poster at the end of the session, but this red road effectively maps to where in the poster it gives you details how to remediate that. And then the last mile is blue and endpoints are green. So basically there's a tab on this spreadsheet. The spreadsheet has the results from each of those queries, and the scorecard view is rendered based on the results of those. So we've given you a bundle that includes all the queries, that includes the script to run all the queries, and then this sample. And what we'll do in the next month or two is we'll automate this. So right now this is a bit of a fudge. So why am I yellow here from AVMC to mediation? Because the average of the poor streams is less than my target. It's actually less than 2%, but I am maxing in certain areas. So there are certain streams that are going over. So that's why it's yellow. And then that little snapshot of the trend shows you that I do have some peaks that are worrisome. And then if I look at wired, why are those guys red? Well, they're consistently over my 5% target. So the idea here is you or your customer can fill in this target column with whatever you choose the target to be. So in this case, I've put our defaults in. So 2% poor streams, 510 for wired and wireless, and then that's a MOS score for device 3.6, a value for glitch rate, et cetera. So you can set the targets that you want, and it'll automatically fill in for you where there's areas for you to look at, and then you can drill into the data. So this criteria column shows the criteria we'll use to automatically render this color, and then the actions are, well, what do I do about this? And then these, if you look at this bottom bit, these, for the endpoints, these become more distributions than trends, right? So you can see the MOS scores for device. I actually have a huge number of devices. I think it's 57% of all streams had less than a 3.6 MOS score. So this particular customer, and by the way, the sample data in here, I aggregated from multiple customers just to make it look worse. So the customers were actually interesting. One had problems in their servers, and their endpoints looked healthy. And the other was the opposite. Their endpoints were a mess, whether it was device, endpoint, or using inefficient media paths, et cetera. So I aggregated them together so you'd get a view. You or your customers hopefully will not be in as bad a state, but that's why. And then the glitch rates, you can see the little graph. They have these huge glitch rates on a huge number of systems, and then it just drops off. They got a bunch of systems that are running just fine. So the thing I would do at first is find a guy on a good system, find a guy on a bad system, do a little bit of a diff. Right? But that's obviously a problem space. VPN's green on this guy because they just had very few VPN streams. The ones they had were poor, but it was such a small fraction of the total that it's not really interesting. And then relay and transport were both problematic because they did have, see if I slide over, you can see, they did have a lot of calls going on relay and a lot of TCP calls. But of course, the target's 0, so anything's going to pop there. Okay. Make sense? Great. So what do we got left? So this, by the way, this little link here, if you click on it, can I click on it? Yeah. Oh, it doesn't show. Oh, there we go. So if I open that up, this is what you're going to see. You'll get all the queries. You'll get some PowerShell scripts that you run on your front end that'll generate all these CSV files for you, and you'll get that. And there's also an instructions on how to run the PowerShell script, and you also get that, that example scorecard I showed you. So pull that down. And now, of course, I probably can't get this off. Oh. There we go.
I will try dying while you sort out the piece.
You'll what? Oh, cough dying? Yeah, I guess I got to get this off the screen. There we go. No, it's back. Jeez. All right, I think we're almost done. So I'm not going to mess with this. So posters, we have posters for you. This is, I think we have enough. There's huge bins in the back. Grab one for your friends. This is CQM. The guys in UA who actually, so you can see the red, green, blue lines, it's the same 10 things, the exact same approach. The guy in UA that did this actually made it a game. So if you download the poster, there's actually a set of game cards and personas. So there's 3 personas. There's the Lync guy, there's the network guy, and there's the telephony guy. And the idea is you can't be successful here until you all work together to resolve these problems. So each one starts in a different path. You pull cards, you figure out how to resolve them together, and you end up in this service management nirvana where you've operationalized this and you've driven out quality in your implementation. So take the poster, have fun with it. Please send feedback to, well, if I could show the last slide, the CQM feedback link. Grab a poster. And I heard that nobody's doing evals. The speakers, the conference guys told us that to remind you to do some evals. So please give us an eval. And that's it. And we'll stick around for questions. Thank you.